Okay, welcome everybody to today's seminar in the AI seminar series. These seminars are presented as part of the activities of the UQ AI Collaboratory. I would like to, this one? No, it's this one. There we go. I would like to start with an acknowledgement of country. The University of Queensland acknowledges the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country, and we recognize their valuable contributions to Australian and global society. So welcome everybody. These seminar series are a way to promote transdisciplinary AI research and collaboration across the university and beyond. Our aim really is to be able to connect UQ AI researchers and students with domain experts and end users and experts in other areas, and to engage with a whole variety of impact areas. So today it is our great pleasure, and personally for me, to be introducing my friend and my close co-researcher, co-author, who is going to give us a seminar on the anatomy of an AI system for misinformation detection and where humans fit in. So for those of you who don't know Gianluca, he's associate professor in the data science discipline here at the University of Queensland. Gianluca's main interests and areas of expertise include information retrieval, semantic web, and human computation. He's got a whole range of funding from ARC, Facebook, Google, Big Tech, and so on. Many best paper awards, publishing very actively in top places such as AAAI, HCOM, ECIR, and SIG-IR, VLDB Journal, and so on and so forth. And before joining UQ, Gianluca was a lecturer at the University of Sheffield in UK. And before that, he was at the Exascale Infolab at the University of Freiburg in Switzerland. Also spent some time at UC Berkeley, and an intern in Yahoo. So Gianluca has been around. That was in Spain. And his PhD is from computer science at Leibniz University of Hanover, focusing on semantic search. And thank you for that slide switch, Chen. So with that, over to you. Please join me in welcoming Gianluca.
Thank you, Shazia. And yes, it is. Good afternoon, everyone. All right, so today I will be talking about misinformation, and more specifically, how to detect misinformation online. I'll talk about how artificial intelligence can help, and my main conclusion will be that artificial intelligence cannot do it by itself, but it can play a role in combination with other stakeholders, namely experts and non-experts. So I won't go through this, but the main message here that I want to give is that I am a computer scientist, and the problem of misinformation is highly interdisciplinary. So what I can do is contribute to it from my perspective, which is that of data science, computer science, and really AI technology, and how AI can help dealing with this rising issue of misinformation. So the work we have been doing recently is looking at how data has an impact on AI, and that's our focus on misinformation as well, how we can collect quality labels to then build AI which is effective in misinformation detection, and how misinformation AI tools can work together with the people to deal with the problem. So just a couple of words about the problem itself. I'm sure I don't need to spend a lot of time to convince you that the problem of misinformation has been increasing over time, especially recently. In the context of the pandemic, we have had misinformation, which created issues in terms of, for example, vaccination uptake in some countries more than others. We have seen countries in which propaganda and misinformation is very prevalent, more than other countries, up to the point in which political elections have been influenced by the presence of and the spread of misinformation online, especially on social media. So that's the problem. The problem is typically addressed in the traditional way by journalists. So what happens is that today we have, let's call them specialized journalists that we call fact checkers, who do the misinformation detection task properly, how it should be done, using forensic methods. They sit in the newsroom, they decide what should be fact-checked, and then they spend a week finding all the sources to debunk a statement by a politician that was done in the previous week, and then they publish an article explaining why that was misleading. That's extremely effective, but it's very difficult to scale. We don't have enough expert fact-checkers to do this at scale, at the scale at which misinformation today is present online. So in this talk, I want to make the point that the solution to the rising spread of misinformation is a combination of these expert fact-checkers, non-expert humans, and artificial intelligence. So if you're not familiar on how we do misinformation detection, that's how we do it. We have multiple steps, and these steps, as I said, traditionally, they are done by expert journalist fact-checkers. First of all, we do a step which is called claim selection. So the goal there is to identify claims made by anyone who are, as they call it, check-worthy, so that it's worth to go through a fact-checking process for. And typically, the criteria with which the fact-checkers decide what to fact-check are based on who is the speaker, what is the potential reach of the claim, and what's the potential damage that the claim may create should it be false. So the question is, what do we fact-check? We have billions of posts on social media all the time, every day. What should we properly fact-check? That's the first step. Once we decided which claim to fact-check, the first step in the process becomes that of retrieving the evidence that allows us to decide whether the statement, the claim is accurate, is correct, is true, is valid or not. And here is where already for some time, the help of technology and artificial intelligence has helped expert fact-checkers to find evidence that can help them decide whether a claim is true or not. Once evidence has been identified and retrieved, then it's the actual step, probably the most expected one, which is the verification. So we have the claim, we decided which claim to fact-check, we have all the evidence available. This could be statistics or demographics information or numbers, whatever the claim is about. Now we compare the claim and the evidence, and we make a decision, which may be binary or maybe on multiple levels, on whether the claim is valid or not. And finally, what typically expert fact-checkers do, they don't really stop there. They write an article which may appear on a news agency website. For example, in Australia, we have ABC Fact Check, which every week is publishing a few fact-checking outcomes, which would be a page, say 2,000 words, explaining why one claim made by a person, typically a politician, may be misleading. And they provide the evidence, they provide the context, they explain why that claim may be not reliable. So these are all the steps in the misinformation detection pipeline. In this talk, I will try to give you some examples on how AI can help people performing these steps. So I'll give you, first of all, an example on how this combination of AI experts and non-experts today works at Twitter. Twitter is a social media platform where users post short statements or claims or tweets. And what they have since the beginning of last year is a crowdsourcing approach to fact-checking tweets, which is called birdwatch. So sometimes a politician may post a tweet on Twitter, and then we have our expert fact-checkers jumping on it and going through the process and potentially debunking it. Now Twitter has introduced birdwatch, which is a crowdsourcing approach to fact-checking. And then, of course, we do have fully automated methods based on AI and data that will go through all the steps and potentially identify misleading tweets. So again, my main message is the solution should be a combination of all these three approaches: the automatic, the crowdsourced, and the expert fact checkers. But let's see how birdwatch works and has worked for a year and a half now. So that's specifically how birdwatch, a crowdsourcing approach to fact-checking by Twitter, is working. First of all, we have a tweet posted by a user. And once tweets appear, again, we are talking of hundreds of thousands of tweets per second, some are selected, this is the first step of the pipeline, to be fact-checked. And then we have these birdwatch users who are users of Twitter who write a review or as they call it, a note about this tweet, labeling as potentially misleading. They have different labels to attach to the tweet. In this case, they say it's potentially misleading. They write a piece of text saying why they think it's misleading. And what they typically do is they add a link to an expert fact-checking source, in this case, PolitiFact, which is a fact-checking website run by journalists, which has already debunked the statement, and they provide this as evidence for their label. Once this note is created, other birdwatch users can rate this review or note of the tweet and support it, like upvoting it, saying it's helpful, or downvoting it, saying they don't agree with it, and explaining the reasons why. And finally, what happens is that we have the expert fact-checkers who do a proper fact-checking, which may take a week after the tweet is being published, with, again, a proper forensic process, evidence, and so on and so forth. So this is how it works. And what we did is we collected data from this platform, Birdwatch, and we looked at how well crowdsourced fact-checking works. So the hypothesis you may make is that as these people are not journalists, it may be completely random the way they do fact-checking. But the good news is that because it's many of them, when you start to aggregate and consider the ratings and numerous people fact-checking the same tweet, then you will see that the results are fairly similar to what expert fact-checkers do. So what we did is, again, we took this data from Birdwatch and we compared it with expert fact-checkers data on the same tweets, fact-checking the same tweets. So we started from 12,000 tweets that had Birdwatch data for them, so fact-checked by the crowd, and then we overlapped it with what was fact-checked by experts, and we ended up with 2,000 tweets that were both fact-checked by the crowd and by experts. First of all, we looked at topics, and we see that over time, there is a fairly similar trend between the two. So the blue line is the crowd and the orange one is the experts. And you see that the trend is similar. For example, here in August last year, this spike refers to a Taliban overtake of Afghanistan, I believe. And in both cases, the crowd and experts decided to fact check a lot of politics-related tweets. So there was, in a way, an agreement on the claim selection step, right, on what they were fact checking. But in other cases, you see that the crowd here around August, September last year decided to fact check more than what experts decided to fact check in terms of Twitter. So there is a potential for complementarity there and for this combined solution, as I was mentioning. So the natural next question is, what does the crowd fact check on Twitter, and does popularity of the tweet as an impact on the claim selection of what is fact checked? Because it does for experts. Experts pick something which is very popular because it has a potential for harm much higher than something which is not popular. And this is what the crowd picks. So on the x-axis, you have the popularity of a tweet, and on the y, how much the crowd fact checks it. And you see there is an increasing trend. So the more popular the tweets, the more fact checking by the crowd we get. But these extremely popular tweets, they get less fact checked because probably they already get fact checked a lot by experts. So the crowd is focusing on these not extremely popular tweets on the platform. Also, something I wonder myself, so that's why we checked it, is whether the crowd has an advantage as compared to the experts of being faster. Because the experts, again, they do it really properly, but it takes a long time and it doesn't scale. The crowd instead has the ability of jumping on the tweet as soon as it's published and fact-checking it immediately, which is very useful if you want to stop the arm of misinformation. And it boils down that instead, in the majority of cases, expert fact-checkers arrive first in fact-checking a tweet, and then the crowd is using that evidence to support their notes and reviews and labels on the tweets they fact-check. But in some cases, we have observed that the crowd is able to arrive before the experts. And again, that's a sign of complementarity between the two groups. For example, you could envision a solution in which the crowd arrives first, but maybe it's not extremely accurate in their fact-checking outcome, and then experts arrive later and then improve the label or the explanation of it. Most of all, are they doing a proper job or not? And the short answer is yes. In this table, the black numbers are the correct crowd decisions. On the rows, you have the experts, on the columns, the crowd. And you see that in many cases, the experts said that something is fake news, and also the crowd says it's fake news across a number of dimensions and so on. So what is bold is the correct, which is the big number, and what is not bold are the mistakes, where the crowd does not agree with the experts. We assume the experts to be the correct label, and the crowd to be mistaken if they don't agree with the experts. So the bottom line is that in the vast majority of cases, the crowd is as accurate as expert, which is a good news if we want to use the crowd to scale up the fact-checking effort that expert journalists are making. All right, so that was Birdwatch, which is a in production experiment run by Twitter to fact-check their content on their platform. And we have done this study to, in a way, observe what's happening there. But rather than just observing, what we also did is running, in a way, more of a control study to answer a few interesting questions on whether the crowd, so non-experts, would be able to judge misinformation themselves without the experts the help from experts. So what we did is we set up a control study, as I said, and we've been showing statements by politicians from the US and from Australia to to crowd workers from Mechanical Turk who were based in the United States. So these people would not be journalists, would not be experts, but they may have an understanding of local politics as they were based in US. So our assumption was that they might perform differently on US political statements as compared to Australian political statements, as they may know nothing about Australian politics. So we showed them these statements and we asked them to rate the truthfulness of these statements on a scale, either at 3 levels, true, false, and in between, or something more fine-grained. So our question is, can they do as good as expert fact checkers or not? And the bottom line is, yes, they can. So what you see here is on the x-axis, you see the expert labels for a statement. On the y-axis, you see the crowd label for a statement, and each point is a statement made by a politician in the US on the left and by an Australian politician on the right. So you see that the scores are not exactly the same, but what you can see is that the median value of this distribution is growing consistently with the rating of the experts. So the lowest rating, the completely false statements according to experts, get the lowest score by the crowd, and the completely true statements according to experts get the highest score from the crowd. So that's a good news. That's the wisdom of the crowd. When we put things together, it works. They are as good as expert. The bad news is that you have extremely bad mistakes, like this statement, which is completely false according to journalists and expert fact checkers. This statement gets a high score by the crowd. So that's a big mistake, as much as this one is a big mistake. But overall, on average, after we aggregate all these labels together, then we have a signal which is consistent with that of the experts, which is, again, a good news in the sense that we might be able to use the crowd, like Twitter is doing, to support the work of expert fact checkers. And the same is true for Australian statements. So we didn't see a difference, as we expected, between US and Australian content, looking at US-based crowd workers. What is interesting is that while on the aggregate level this works, if you start to break down things, you see very interesting phenomena. So here in this plot, we see the same thing like before. On the x-axis, the expert journalist labels from completely true to completely false. And on the y-axis, the crowd labels. But now this box plot is split into two, and we are coloring the non-expert crowd workers blue if they voted Democrats in the previous election, or red if they voted Republican in the previous election. And then we show them only statements by Republican politicians. And what we see here is that at each level of truthfulness, being it completely false or completely true, the red crowd workers are more generous towards the red politicians as compared to the blue crowd workers. No surprise at all, obviously. So if you are aligned with the political thinking of the speaker claiming something, then you are more likely to believe to it. Well, guess what? No surprise. But what does this mean? What this means is that who is doing the fact-checking task really influences the result. So the typical approach in crowdsourcing is that the crowd is uniform. We pick randomly people from the crowd and we ask them to do something. But what this shows is that we shouldn't do that, because depending who is the member of the crowd, the label may be different. So if we get, by chance, all red crowd members, then we get a different label than if we get all blue crowd members. And this is true not only for this task in general, right? We are training AI with human-generated label without caring who the humans are, but this shows that we should care about who are the humans producing labels with which we train AI. Okay. So following this line of research, so far we have seen that on aggregate, the wisdom of the crowd is able to replicate the decisions made by experts. When we put them all together, and they are able to identify misinformation that has been detected by experts. Now, the question is, how do things change over time? With the ability to tap into the crowd, we are able to see whether things are consistent over time or not. We have already seen in this result that results are not consistent across members of the crowd. So we wanted to check whether results are consistent over time. So what we did is we repeated the same experiment multiple times at 1 month distance. So every month we were asking new people to fact check the same statements. And then next month, so we did this in May, in June, we asked new people to fact check the same statements. And then in July, we asked the new people to fact check the same statements. So every month we get 100 new people to fact check statements. And then we also invite the people who did it the previous month to come back if they want. So you see around 20% came back of the 100 that initially started, but at least we have every month 100, a group of independent people who do the same task again. And this was run in 2020, and the statements we were showing them were related to the pandemic, which was happening at that point in time. So what we observed in this interesting experiment, which was, again, looking at whether things change over time, is that, again, the same thing as before. When we aggregate judgments, there is an agreement with experts. Again, the correlation is the same. So same good news. The crowd workers are able to complement expert fact checkers by obtaining similar conclusions. But when we look at things over time, we also observe other things. For example, when we compare May and June versus May and August, we see bigger differences between May and August as compared to May and June. And these were independent group of people. So what really matters is the time here and how the understanding of the truthfulness of these claims has been changing over time in the public understanding. So I'll give you one example. At the beginning, in our dataset, there were claims by the US president about one specific drug being effective for to cure the virus. And through the months, debunking has happened and more evidence has shown that this drug is not effective on this virus. And the crowd, in a way, adjusted their labels through the months, making use of this additional evidence that appeared between May and August. So we really see this difference as time went by. The early labels that we saw were more different from the latest label as compared to the close by labels. So again, this is just one experiment, but it's another signal of potential bias that tell us that depending on when we do the fact-checking task, then the results may differ because the evidence available is continuously evolving. So remember, we have this second box of evidence retrieval, and that will, the data feeding into that box will continuously change every minute on the web. So even if we keep the technology and the process the same, the underlying data may be different, and this may influence the final outcome. Okay, so last piece of work on the fact-checking task, and then I will go to the last step in the process, which is that of explanations. Misinformation is a very, as I said at the beginning, it's very interdisciplinary, it's a very complex problem, and the definition of what is true and what is not is also subjective. maybe even saying that is subjective is subjective. So it's a very complex concept. So what we were wondering is whether there are different dimensions of what we should consider truthful or not. And again, whether members of the crowd, non-experts, are able to exploit different dimensions in this task they are doing of fact-checking the veracity of a statement. So we started from our standard task that I've talked about. We show a statement and we ask members of the crowd to tell us whether they think it's true or not and why. But instead of asking this on a single scale, which may have multiple levels or just a few, as I said, now we expanded the scale on multiple dimensions. So rather than having, say, a slider or radio buttons where they pick between 3 or 6 or 100 options, now we have a table or a matrix of, for each dimension, you tell us how much this statement reflects that dimension. So that's how we change it, and we wanted to see whether this makes things better, whether the label we get are more reliable, better quality, and more similar to that of experts, whether these dimensions are correlated one each other. So if something is false, is it false on all dimensions or just on some of them? And which are more important for a final decision of something being fake news or not? So these were our main questions here. And these were the dimensions. We didn't invent them. Again, we are taking from very well, we are starting from very well grounded research on what is misinformation and how it's defined and how it's measured from the social sciences. And these are 7 established dimensions of how to detect and measure truthfulness. So for each of them, we asked our participants from the crowd whether they believe a statement is correct, is neutral, it's easy to understand, it's precise and complete, whether the speaker is trustworthy, which is making the statement, and whether it's informative or not. We don't just throw these 7 dimensions to them, we explain it to them, we give examples of something being precise or not, neutral or not, complete or not, and so on, so that they are able to do the task to the best of their abilities. And again, I will skip all the fine-grained results, but the bottom line is that the crowd workers are able to leverage these 7 dimensions and provide reliable labels as good as the expert labels. And also when we compare these different dimensions, we see that they are independent. So they don't really measure the same things. All of them measure something different, and a statement may be more like worse on one dimension and better on another dimension. We also try to combine these 7 in a single label, but we actually didn't manage to get a label better than the one the crowd workers could provide by combining these 7. So there may be an option to do that. We just didn't manage to combine them in a way that give us a better label. So I think the main lesson learned from this study is that while, especially from an AI training point of view, we might be more interested in having a single label because we want to give examples to a machine learning model of this is fake, this is not, learn to do it. I think what we have seen here is that asking and showing all these different dimensions to the members of the crowd helps them to make a better judgment, because makes them think of which are the criteria with which they should make a judgment, and then in the end they do make a more reliable labeling as compared to when they don't have these different dimensions. Okay, so we went through a few studies that hopefully convinced you which you may not have expected at the beginning, that non-experts may be able to fact check and identify misinformation online at the same level as expert fact checkers could do. Now, with this, I don't really want to say that we can get rid of journalists and expert fact checkers. I don't want to say that we can replace experts with non-experts. And especially, I don't want to say that an AI trained on this data can get rid of human beings completely. What I see as a future is a combination of these three things together, working in a more optimized way in order to achieve a result which is effective and efficient and scalable. And that's where AI can bring scalability, experts can bring high quality, and the crowd can bring something in between by being fast, by working at a bigger scale, still being effective. So where I see AI and crowd workers helping is definitely in the claim selection, because they can be faster, as we have seen. But in the end, we also need the experts here to tell us what is potentially harmful and what is check-worthy by following their own processes. It's just that it will take more time. We spend a lot of time today talking about this claim verification, and we have seen that non-expert crowd workers in different ways, in different settings, they can produce labels which are reliable. So let me now talk about this last step, which I think is very important for people to trust the outcome of a misinformation detection process, which is that of explanations. So in the last 5 minutes, I will talk about how we can use artificial intelligence to generate explanations together with making a misinformation decision using artificial intelligence. So the reason why we need to do this, it's really not an optional step, is that we cannot expect to build an AI that does fake news detection, deploy it on Facebook or Twitter, and hope that people will live with it, right? If you tell me this is fake and an algorithm has decided that, well, I don't care, right? It's my judgment is better than that of an AI. So we should never expect that people believe that something is fake news just because an AI has decided so. So what we really need is to work with people and convince them about why something may be misleading. And this is an example of an AI architecture that does generate an explanation together with a decision, a classification of whether something is misleading or not. This is the most technical slide I have, so I apologize for it. But this is a standard encoder-decoder architecture in which we have this joint head. So this is the real contribution of this work, in which on one side we generate a classification decision. So this may be a binary label, true or false, of an input statement. But in parallel to that, we also generate an explanation, a natural language explanation of why something is true or false. And we train this architecture using expert labels as well as expert explanations of why something may be true or false. So rather than going in the details, again, I'll give you one example of how this works. We have a claim made by someone. We have some evidence. Remember, the second step after we select which claim to fact check is evidence retrieval. So we retrieve some evidence relevant to the claim. And then we train our model using labels from experts and explanations from experts. And then we have our model generating an explanation for other claims. So this is comparing the explanation that our model generates as compared to the explanation that the expert fact checkers have generated for this claim. So the question we had here was not only how good the label that the model generates, so not only these classification decisions that the model generates, whether they are good or not, and we can easily do that by comparing the decision made by the model with the decision made by the experts. We also wanted to know how good the explanations are. So let's focus on that. Let's try to understand whether these explanations are good and useful for people, because that's the bottom line. So first of all, we asked the people whether they prefer the expert-generated explanations or the AI-generated explanations. And we see that it's like 50-50. Enough of the cases, the preferred explanation is the one generated by our model, and then the other half is the one generated by experts. And we also don't see a difference on whether the statement itself is true or false. So this is good news. At least from these results, we can say that the explanations that we were able to automatically generate with this model are comparable to that of expert. But we did one more step. So rather than just asking people, do you like this better than that? We wanted to understand whether these explanations, which can be automatically generated, so it's very scalable. You can do it for any claim on the web. You can not only attach a label to it, but you can also have a natural language explanation of why that may be false. We wanted to understand whether that's useful for people to identify misinformation by themselves, because I think that's the bottom line of how to fight misinformation. So what we did is we went back to our task. We show a claim to people and we ask them, is this true or not? And that's our task. Additionally to this task, we have another variant of it in which we show the explanation either from the expert or from our model. So the assumption here is that if I show you the statement, but I also show you an explanation which can be automatically generated, can you spot misinformation better than if I don't show you and just you see the claim? And it's not as easy as we imagine. So the results, when we add explanations, things do not get better. So here on the diagonal, you have the right answers. The crowd says something is true and the experts have said something is true. And here the crowd, the participants said something is false and the expert says it's false. So these are the right and these are the mistakes. And you see that we don't have less mistakes necessarily when we add explanations, whether they are experts or not, or AI generated. People are not more accurate in spotting misinformation when they have explanations. That was our hope, but it's not as easy. What instead we can see, which is good news here, is that there is a decrease in, there is an increase in these errors, in false positives, in false negatives, where the crowd says something is false, but it's actually true. And it's true whether you put the expert explanation or the AI-generated explanation, there are more of these mistakes compared to when you have no explanation. So this means that explanations make people more skeptic about whether they should believe of what they see online or not, right? They tend to see more that something is false, even if it's true. Which is not, again, accuracy may not improve, but I think I'm happy with that. I'm happy for people to be skeptical rather than believing to anything they read online. All right. So that's all I could talk about today, given the time. We've been talking about misinformation and how this is a complex task that does require experts, but also we have been looking at ways to help these few experts, which really do not have the resources because there is no really business model behind this fact-checking task yet, how we can help them, either by providing tools based on data and AI, or by having non-expert humans, maybe both of them working in combination to help experts detecting misinformation online as quick as possible, at a larger scale, and as accurately as possible. We've seen that the crowd can be fast, can be accurate, and can scale thanks to AI, especially in tasks like evidence retrieval, where automated solutions can do things really efficiently and really at scale, and also in generating explanations, natural language explanations, which typically is something that experts are deeply involved in and spend a lot of time in. The thing to pay attention to is that of bias. I think that's a very important lesson I learned in the last few years. I work on this area, is that different people provide different labels, but it's not random. It really depends on who these people are. The labels you get depend on who the human annotators are. So we must pay attention to identify the right human annotators for an annotation task in order to get the right data that we then use to train artificial intelligence. Thank you very much.
Okay, we have time for questions. Okay, Ralph, go ahead.
Thanks for the talk. I want to go back to the study where you differentiated between Republicans and Democrats. I mean, the good news is that even the Republicans, the order was kind of correct. It just shifted a little bit in the scale. So this is a good news, because I have the feeling, if I look at the US news, the more outrageous the lie is, the more it seems that people tend to believe it more, but this seems not to be the case. So that's actually a good sign. So even if you're on the other political side, you're still able to detect fake news somehow correctly, right?
That's what our data shows. It's hard to know what's true. I think there is a lot of, there are few people who are very visible, but then there is, if you look at the big numbers, it's a bit less bad, the thing. Bad things we see are also dependent on how election systems work, and like swing states and things like that, where politicians can focus on very small groups of population and have a big impact on election outcomes. I think all that plays a role in how we see things happening, but I think it's not as bad as you say, if we look at the general population, and that's what these results also seem to imply.
Thank you, Gianluca, for the great talk. There's so many great things to reason about. And it made me thinking, your results, your different results, made me thinking a few things. So the last one, made me wonder, the last one about the explanation, make me wonder if, the decision of people in terms of whether they trust or not the explanation depends also on the quality of that explanation. And, you were showing us one example, you only show us one example of an explanation, and the gold explanation, the one from the expert, didn't seem anything I would trust, right? And so I wonder if those results that you showed us at the end on people giving the wrong trustworthy, the wrong, is this correct or wrong decision, let's say, is because of the explanation wasn't really good, even that of the expert.
Yeah, no, good point. It may be. I think it's worth exploring more and see whether there is a correlation between explanation quality and accuracy. we would need a way to measure explanation quality, which to think about, yeah. And especially having different levels of quality of explanation, and then we could try to measure whether your assumption that better explanation lead to more accurate labels is true or not. I think it's an interesting experiment.
One of your earlier results, you had that box plot where you had the expert labels, I think were on the X, and then you had the boxes and the distributions that were the crowd labels. And my understanding is that the dots were different topics, right? Different statements. And you had some statements that the experts say they are lies, and instead the crowd sometimes, for some of these statements, they also say they're lies, or for other statements, they say these are true. And I wonder what is affecting the errors that the crowd is making. Why is the crowd making this error? And when I think of this, who knows, there are many different factors, but then I put these together with what you showed us at the beginning of the crowd being able to give very good fact checking on things for which there is easy reachable evidence, the PolitiFact database, then I wonder if those topics, those statements for which the crowd fails, are those statements for which it's very hard to get evidence. So, the only thing in that pipeline you didn't talk about was the evidence retrieval. And I wonder if the difficulty in retrieving evidence, or the quality of the evidence retrieval system, influences how good the crowd can be.
As it may be, I think there are two possible reasons why a statement gets lower accuracy than other statements. One reason is the one you say. The statement itself is difficult, or it's difficult to find evidence for that statement. And the other possible explanation is the human annotators. If the sample of human annotators we got for that statement is significantly worse than the annotators we got for the other statements, then you get a worse label. So I think it's really one or the other. It's either the content or the annotators. And I don't know. So the Democrats Republican plot shows you that the annotators matter. And that was a political bias, but it could be a quality issue as well. That your sample is biased in terms they are not good in doing the task. But it may be the statement, as you said. I think it's either one or the other. I don't know which one. Or both. Yeah, both is possible. So each statement, in most of the experiments, each statement is annotated by 10 different people, randomly selected.
Okay, yeah, good line of questioning, Guido. We also have got a question from our online audience, from Amin, actually. The crowd seems to be the source of info to tackle misinformation, but that crowd can be artificial. That is fake. Maybe Amin is talking about chatbots. Yeah, thousands of bots can be used to generate many thousands of tweets to support a released misleading tweet. Misleading tweet on a specific topic. How can you then rely on that crowd and differentiate between genuine and fake crowd?
Good question. I think that's an orthogonal problem which boils down to identifying the human annotators. What happens in practice, what social media platforms do is they do employ physical human beings in the order of hundreds of thousands of people to do annotation of data as a full-time job. So those are people who are human beings. And that apparently has been working. A lot of money has been invested in that, and the different social media platforms all follow that approach. If we do this externally, as we do, then I agree with Amin, it's more difficult to know whether you're chatting with a dog, a human, or an AI today. you never know who's on the other side of the screen, like we were saying in the 90s. But if you do this at the production level, at the industrial level, then we have control of this crowd, and this is what's happening in practice today.
Like in birdwatch.
So birdwatch is a I think more innovative step in that direction, but Facebook has hundreds of thousands of let's call them contractors. They are not employees because they don't get the benefits of being a Meta employee. They are hired through outsourcing companies, and they work on Facebook data to do annotations, but they are in a way controlled. They work in a controlled environment, and they do this type of tasks at the scale of Facebook data. Birdwatch is more crowdsourcing, is not outsourcing, because the people are less controllable. They are still today selected Twitter users. Not anyone can do a birdwatch review. They are still Twitter approved. So I think the risk, I mean, is talking about would not yet apply to birdwatch, but if they open up to anyone, then yes, absolutely,
Then
we
there
could
is
have
a
bots.
Potential of bot
making the
infiltration.
decision. Absolutely.
Okay, okay. We have one more question from the audience here. And then the online people will hear you too.
And using the explanation to help the experts making a decision. Oh yeah. Yeah, no, that's a very good point. So in the last couple of years, ABC Fact Check has been, they are very sensible on being helped. But what they have appreciated help with is on the check worthiness. So deciding automatic ways to help them decide what claims to check, and on the evidence retrieval. But maybe the explanation could be another step in which they could have a starting point, right, at least, and then expand on it. Yeah, it's a good idea.
Ralph.
And correctly, you show the explanations to the crowd, and then the crowd decides whether it's fake or not.
Exactly. So I show the statement they need to judge, plus an explanation, and then they need to say the statement is true or false.
Then they are already biased by the type of explanation. So shouldn't you show two explanations? One that explains the statement is true, and one explanation that kind of shows that they can decide which is more believable.
I agree with you. They are biased, and that was indeed the purpose of the experiment, to have a controlled control group with no explanation, and then one with an explanation and one with another explanation, and see the amount of bias that the explanation gives them in leading them towards the right, hopefully, label. But actually, the results show that they don't necessarily improve the quality of their labels. Showing them two explanations, maybe, but then the quality of the explanation will have an impact, like Guido was saying, on their decision. So you bias them on one more dimension, and we don't have it.
Inherently biased. So you make an explanation towards a statement.
Yeah, it is. It is biasing them. It is priming them in a certain direction. I think that was exactly the purpose. Every piece of information we see online is biasing us, right? To believe that a vaccine works or that a politician will make the world better. It's all information which is biasing decisions. So that's what we are doing with explanations.
Very, very good line of questioning. We are almost out of time, but I cannot resist asking one question, Gianluca. So a lot of the work that you have been talking about is been alignment of the crowd judgment with the expert judgment, understanding that experts are expensive and they do not scale, but your research is showing that the crowd judgment can come pretty close to the expert judgment. So my question is, how much of the crowd do you need? Do you have a sense of, because crowd is also not free. So does it depend on the context? Does it depend on the task? How do you determine when to stop your crowd study?
Yeah, it's not much of the number, but who they are, as I said earlier.
Okay.
So if you have good ones, one is enough, right? If you have an expert, one is enough. If they are not so good, then you may need more so that the wisdom of the crowd emerges and you get the correct answer. I think the better answer to your question is that it's not even who they are, but really envisioning a solution which combines all these things together, having some crowd workers, and then if they cannot agree or they cannot find a label quickly, get an expert on board. If few crowd workers can do it properly, they are in alignment on that, that's it, we stop. We could throw an AI in it and maybe making a first quick decision in the order of milliseconds and then get the crowds to check it and confirm it or refuse it. I think that's the better approach to it, an hybrid human machine experts, non-expert AI solution that gets the best of the two worlds.
Especially in the absence of ground truth, which your studies had, but in reality, we don't
in reality,
have.
you don't know, right? So you need to have an estimate of, are we done yet or not?
Yeah. All right. So I think we may have a few more questions, but Gianluca, just one more question? Yeah. Okay.
For the talk, I have a question about the reusability of the model. How can I use the model in different languages? Do I need to retrain the model in the different language, or can I use? Yes. And
Gianluca,
also,
can you repeat the question? Yeah.
Will that be a bias if I use a model for example, for people in America and people in Asia? Yeah. So, thank you.
So the question is about generalizability of the model to multiple languages, but also to multiple cultures around the world. We didn't really look at that. We worked on English language only. So the things we have developed have not been tested on other languages. But my assumption would be, especially when you involve non-expert participants, is that if you do have non-English content, but then you have non-English participants, things may apply, the results may be consistent, but I cannot claim that because we didn't try. So I don't, the reality is I don't know. I imagine they could be. In terms of different cultures, that's a very, yet a very important point. What happens today is that, especially social media, is defining a standard which is valid throughout the world, but is based on not even US, it's based on California kind of standard. And that is applicable everywhere. But what's interesting is that the human annotators are not based in California. They would be too expensive. So they are based in Philippines mostly. And while they apply the guidelines defined by the platform, they have, of course, these are very subjective decisions they need to make. So they have this freedom to apply their own cultural understanding to the content and then label it in one way or another. It's a very difficult field to move into, especially when we have artificial intelligence trained on these labels generated by humans who have a cultural background and apply Western guidelines. It's very complex. So I think a lot of mess is happening in these pipelines. and no one is really able to measure it yet. But I think you're right. There is there are variabilities, and they are all mixed together in the same pipeline at the moment.
Yeah, I think we should wrap it up now. There was one more question, Gianluca, I answered on your behalf about an experiment. So I was clear that you had done that experiment without explanation. So with that, please, everybody, please join me in thanking Gianluca for a very enlightening talk. Thank you, Gianluca.